Okay, so we have like a basic AI working for our character. It can detect when the player is within range and do an attack motion. Our character can attack, has air attacks, and so on, controlled by a state machine. The enemies are a behavior tree, um, obviously along with a navigation agent, and they move along the navigation map. But they can't actually damage each other yet. So we're going to add that in as kind of a wrap up to the course. So in order for a character to damage another character, you're going to have first off some kind of health component. And then you'll pick that up from the character trying to hit the other character and deal damage to it by subtracting an attack value. So I will try to keep this straightforward. We would want maybe in character stats we'll have like a damage. So let's say stats, character stats, and let's just add in at export var damage, which can be a float, and I'll default it to 10. Okay, so now we'll be able to read from that when we are dealing damage to an enemy. So for our attack, we need it to have kind of a attack collision or attack collider. And that's going to be attached to an area 2D. So I will right click on facing. Let's say add child node, area 2D, and we'll just call this attack area 2D. I'll right click on it, attach a script, and this will go under characters because the player is going to use the same script. So create the script. We'll just call this class name attack area 2D, used for hitting health components. Sure, let's go with that. Okay, so a lot of this is going to look kind of like the detection zone, where we're going to connect to its own signals. So inside of here, function ready, we're going to have body entered dot connect on body entered. I think we only need the body entered though, because we don't really care about when it leaves the zone. We're only dealing damage when it enters. So function on body entered, which is going to be a body as the parameter, of course, node 2D. So if the P body is a character, let's just say. So if we're hitting a character with the attack, then we can kind of access the stats on the character. It could be a separate health component, but I think basically any character in these kind of platforming games that have attacks are just gonna have like a health stat too. So in character stats, I'll just even put in the at export var health into here. And let's just make it 20. So a character can take 2 hits before dying. We could also make these integers. Most games, they don't really deal floating decimal point damage, so that would make it kind of unnecessarily hard to read. It's easier if you just see like 10 rather than 10.0 or 10.5. So if the object that entered was a character, then we'll say p body dot we'll create a hit function and we'll pass in the amount of damage that we're going to deal. So we need a reference to the character stats. So let's say at export var character. So this is the character doing the hitting. And you might like have multiple attack damages, like you might attach the damage value to the attack area rather than the base script. That actually makes sense. Let's just put the damage in here. At export var damage equals, it's an integer, and I'll set it to 10. And then we'll remove damage from the character script. The reason for doing that would be that you might have different types of attack areas for, let's say, different attacks. So being able to set a custom damage value for each one is pretty handy. To go beyond that even further, you might have like resource files which contain attack values like, oh, the name of the attack, the damage of the attack, so on and so forth, kind of like an ability system. But once again, keeping it simple here. So we're going to hit the other character with the damage from this attack. And that is pretty much it. What we can do is say var damage dealt, and then we can print, let's just say dealt %s damage to %s. We pass in an array, so percent and then array. And we're going to do damage dealt and then pbody.name. Okay, that way we can just see that this is actually working while we're kind of testing and debugging the game. So our attack area here is going to collide with, of course, players. So set that up, and we want it to be essentially not triggering by default. So the way we can do that is by adding a collision shape. And this will be, let's say, a rectangle again. And I'll just kind of make it the shape of the attack, which we can see there. I might pull it in a little bit, make it a little more fair. And then this is going to be disabled by default, of course. So we can do that by going to the animation player, going to reset, add track. So the collision shape here, we want to set it to disabled. Insert key, snapping to 0.1, and then make the snap to 0.0, disable it. Okay, so that means after an animation finishes and it resets back to another animation, it's going to disable the collision shape. So hopefully we won't have to worry about it triggering like that on other animations that aren't this one. So here, yeah, we can see that we need to add in the, first off, we need to enable the shape. So disabled should be off here. And then we need to stretch the shape depending on which frame it's at. So I'll click on the collision shape. Let's go to transform, keyframe the scale. Might as well keyframe the position as well. Go to frame 1, increase the scale X to fit our frame 2, and then keyframe it. That adds a keyframe point down here. Next frame, we can go a little bit further like that, keyframe it. And then by here, I think it already should be disabled. So I'm going to insert a key actually, and we're going to disable it there. Okay, and we might want to play that animation. Oh, okay, so we can see it's kind of like automatically growing with time, but because it's pixel art, we want to change this continuous scaling to discrete, so it only changes when the keyframe changes. So now it's going to look like this, right? Much more appropriate for this style of game. Okay, so that's going to enable the attack area, which already calls hit on the character. So let's jump into the character script. We go to character, we'll create this hit function. So P damage, right? That's how much damage it's going to take. And we're going to say stats.health minus equals P damage. And we can go into character stats. You might have like a max health here. In the actual game, you might have like a max health here, and then whenever the character gets created, you set that starting health to the max health, but I'm just going to skip that. But when the health gets set below 0, so I'm going to do a setter on the property here. So set value, health equals value. If health is less than 0, then I'm going to emit a signal. So our stats resource can have its own signals. So signal, I don't know, health depleted. So if the health is less than 0, then we'll say health depleted dot emit, and now we can react to that signal. Okay, so on the Captain Clown nose, let's add in another state on the Captain Clown nose. So this will be a character state. I'm gonna rename it to be dead state. Okay, so for our dead state, we want to be able to transition into this when the character's health drops below 0. So one way of doing it would be to go onto the HSM and let's add an event handler. And then let's bind a signal to the character stats. So I'm going to say character.stats. Oh, I see this is still a character body 2D. Then let's make that a character. Okay, and that doesn't unset the reference here. So character.stats.health depleted, and we'll say connect to on health depleted here. Come down here to the bottom. On health depleted, we want to just change the active state to be, let's say, states dead. Okay, so then we just need to make sure that dead is added in here. So assign the dead state, add key value pair, and that's how we're going to get to that. So when the health is depleted. Now let's see, in character stats, when we do this, I also want to make sure that the old value was actually above 0, so that if the health keeps dropping below 0, like 0 to -5 and then to -10, that we don't keep emitting this. So we'll get the old value. Old value equals health. So and old value is greater than 0. So only when it drops to 0 or below 0 for the first time are we actually going to emit that signal. Okay, and then on dead state, well, we have the animation name here, so we just need to play the animation, which we haven't created yet. So let's go to idle. I'll duplicate that. Let's call this the data animation. Put data over here on character state. Change the animation here to dead ground, sure. Hit play to test. Okay, looks like this is a 4-frame animation. It should not loop. So unloop it and then change it to 0.4. Can hit play there. And what we can do is at the end of this animation, we'll just do a call method track on the character clown nose, insert, and then cue free. So that'll just remove the character from the game when the character dies. Let's hit play and see if the character can actually take damage. Oh, there we go. And yeah, it looks like it takes 2 hits to actually defeat the player. So that was pretty much exactly what we were looking for. We want to kind of do the same thing with the crab now, right? So for the behavior tree, let's see. I would say we want to bind the health in the behavior tree so that we can actually keep track of that. And then if the health drops below 0 here, then in the tree we'll have a prioritized sequence here where it'll just destroy the crab. So let's click on BT player, edit. We'll add in a health variable. Actually, we don't need it because it's actually already on character.stats. Okay, so let's click on BT player and we're gonna add in a health variable, which is an integer, health of the character. And then we're gonna go to Krabby. So this is the NPC. So the NPCs are all basically behavior tree based. So we should just bind the stats to the behavior tree. So I'll say function ready, and we'll say stats.health. We'll say bind. I guess we need to reference the behavior tree for that to actually work, huh? Okay, so at export var behavior tree dot player underscore player bt player. When we load that, then we'll get the blackboard. Okay, so blackboard equals the bt player dot blackboard, just like before. And now we bind on the blackboard, blackboard dot bind variable to property. We're gonna do bb names dot health var. That's going to be equal to, I guess the stats is the object and the property name is health. So assign the BT player there. Health var doesn't exist, so jump into BB names. Put in static var, health var, string name is equal to health. Okay, back on that script, we just save it. Make sure everything's still assigned here. I'll reset these animation names. Make sure they match up with these down here. Okay, and then we can go to LimboAI, create another sequence here. We'll call this defeated sequence. So first thing we're going to check is if the health var is equal to 0. So the type is integer, the value is 0. If health is 0, or actually less than 0, less than or equal to 0, then we're just going to play the death animation on the character. So this would be animation. Let's get the animation player here. And then we're going to play dead animation. And then we need to create the death animation on the animation player. So yeah, let's duplicate the attack. We'll call this dead animation. We delete the collision shape stuff. We're going to leave the lock animation unlock animation because we still need that. And we're going to change the animation here to dead. Okay, so let's go up here. Let's hit play. And I don't know how many frames that is, so let's check dead ground. Oh, okay, it was actually 4, huh? So this is already almost what we need. We could add like a couple extra frames here for the duration, and then move this over here if we want the character to stay dead on the ground for a second. And then let's do a call method on Krabby. We're going to free here. So cue free. Hit play, and that should mostly be working. We just need to have the attack. So we have the sword collider here. Let's add in the attack script. So attack area 2D, drag and drop that to here. We have the damage. Okay, first off, let's reload the current project because it seemed like there was some animation path issues. So that usually fixes things. We hit play, we go over here. Okay, our character died. Let's change the player's stats to be higher. We already know it can die, so let's just make it 200 so that we definitely don't die. And then let's try to go and swing at these enemies. So that guy died. Oh, I see that they're all of their health is actually linked up. So what we want to do, if we go into the NPC script here. So let's see, character stats. I think we'll just want to like duplicate this immediately. So we're going to say stats is equal to a duplicate of the value. or value.duplicate. Okay, this means that for each active character, it's going to have its own stats. They're not going to share the resource directly. Otherwise, they would all die at the same time because their health values are all shared together. So now if we hit play and we try to damage these characters, you can see that they don't die at the same time. So that's more like what we're looking for. And all the death animations are able to play. So if you're interested in like hit knockback and that kind of thing, I have other videos on the subject, but I think I'm going to actually wrap this series up there. The main things we covered is how to set up some examples of a branching behavior tree. So here we have death if the health changes to below 0, which is our first priority. We can attack if we have a target, which is picked up by the sensor. And then if we have a fallback, then it's just going to navigate around the map until we find a target to fight or until the player hits and kills our character. Then on the clown nose, since a player character doesn't really need its own AI logic, we just set that up with a Limbo hierarchical state machine, and that just allows us to transition between the different states that have different properties about how the character can move or not move, and creating all of the transitions from within the state machine's base script. So there is a lot more to cover on the subject, but I hope that this video has given you a good introduction, that you'll understand roughly how to use state machines and behavior trees as well within a Godot game using LimboAI. Although I used LimboAI for the video, if you want to check another example of a behavior tree system, Behave, spelled B-E-E, like a bee, and then have, is another good option for within Godot. So you can definitely kind of compare those two and see which system works for you. But that's going to be it for this series on LimboAI. If there's enough support for it, then I might make a full course at some point. Let me know what you think, what you thought. Did this help you out, etc.? And until my next video, I've been Chris. Thank you guys for watching to the end, and I will see you in my future content.